Alright, in this video we're going to talk about solving quadratic equations by factoring. Alright, so first off, what a quadratic equation is, it's an equation where we have an x squared or an x raised to the second power, and that's the highest exponent that we have. Alright, so a quadratic equation is one that's in the form or is equivalent to the form ax squared plus bx plus c equals 0, where the a, b, and the c are real numbers, and they can equal any real numbers except a cannot equal 0. Right? And the reason we have to put that stipulation in there that a cannot equal 0 is because if a was equal to 0 and we had 0x squared, well then we wouldn't have an x squared there, we would just have bx plus c, and then that's not a quadratic equation because it doesn't have the x squared, so that would just then be a linear equation, right? So now for a quadratic equation, the b or the c could equal 0, that would be okay, and a could equal any other real number besides 0, right? So to have a quadratic equation, you have to have that x squared term in there, and the second power is the highest power that you have on the x, right? And there are a number of different methods for solving quadratic equations, and I'll do videos for all these different methods. And this one we're just going to work on the factoring method. And the factoring method doesn't always work, right? You cannot solve every single quadratic equation by factoring. But if you can solve the quadratic equation by factoring, that's usually the quickest way to do it, right? Some of the other methods that we'll talk about also only work once in a while. There is one method using the quadratic formula that works all the time, but that's usually a little bit more time-consuming than factoring. Right, so when I'm trying to solve a quadratic equation, usually the first thing I try to do is see if I can factor it, and if I can, you can get the answer pretty quickly that way. If you can't factor it, then you try to use one of those other methods that we'll talk about on other videos. All right, so if you're not that comfortable with factoring, or if you haven't watched the videos that I did about factoring, I would advise you to watch some of those. Factoring is a really important skill to have when you're doing algebra and into precalculus and calculus. It's really important to be able to know how to factor. It comes up in a lot of different types of problems. One of those is solving quadratic equations. It also comes up when you're solving other types of equations. Factoring also comes up in a ton of other types of problems as well. All right, so very important skill to have. Right, so in order to solve a quadratic equation by factoring, or really any type of equation by factoring, we use something called the zero product property. Right, so what the zero product property says, right, so product, remember, means the result of multiplication. So if we have two things multiplied, a times b equals 0. Right, well, the only way I can multiply two things together and have it equal 0 is if one of those things is already 0. All right, so a times b equals 0 if and only if a equals 0 or b equals 0. All right, think about it. I can't take two numbers that are not 0 and multiply them together and have the answer come out to 0. Right? The only way I can multiply two things and have the answer come out to 0 is if one of the numbers I'm multiplying is already 0. Right? Positive numbers and negative numbers, fractions and decimals, you can't multiply those together to get 0. Unless you've got a 0 to start with. 0 times something else is always going to equal 0. And that's the only way you get a product of 0. Right? So we can exploit that zero product property in order to solve quadratic equations. If I can get my quadratic equation equal to 0, like in this form up here, and then I'm able to factor it, whether it's a trinomial or a binomial or whatever type of quadratic equation is, if I'm able to factor it and get it as two things, or even more than two things, 2 or 3 or 4 things multiplied together that equal 0, I can then separate those factors and set them equal to 0 and then solve from there. All right, so that's how we go about solving a quadratic equation by factoring. Remember, for different types of equations, you have to use different methods in order to solve them. Right? For linear equations, all we do is just move stuff like add and subtract stuff over and then divide to get the x by itself. That method does not work for quadratic equations. All right, if you think about it, with this example here, x squared plus 5x equals 24, if I try to use the method that we use for linear equations, well, how am I going to do that if I have an x squared and I have a 5x? How am I going to get the x by itself when there's two of them here and they're raised to different powers? Right? I can't just add these together because they're not like terms. If I try to subtract the x squared here and divide by 5, I would get the x by itself, but it would be equal to something that has an x squared in it, and that doesn't really tell me what x is equal to. Right? So for different types of equations, you have to use different methods. So really the first step of solving any equation is identifying what type of equation you have. Right? If all you have is x is raised to the first power, you've got a linear equation. You just add, subtract, combine like terms, divide to get the x by itself. If you have an x squared, that means you have a quadratic equation, and the linear method doesn't work. You got to use something else, and one of your choices here is factoring. right? And like I said, there are a couple other choices which I'll cover in some other videos that I do. Right, so to solve this equation by factoring, x squared plus 5x equals 24. Right, first thing, remember, when we're factoring, we're using the zero product property, which means we have to have our equation equal to 0. This one is not. X squared plus 5x equals 24. Right, I can't factor the left side of the equation and have it equal to 24 and then try to use this zero product property. It only works if it's equal to 0. Right, it doesn't work if it's equal to 24. Like if I have two things multiplied together that equals 24, that doesn't really tell me much, right? It doesn't tell me that one of those things has to be 24. Those two things that multiply to 24, it could be 1 times 24, it could be 2 times 12, it could be 3 times 8 or 6 times 4, it could be 48 times 1/2. Right? There's lots of different things that could multiply to equal 24. We can only solve by factoring if we have it equal to 0. Right? So if it's not equal to 0, your first step, long story short, is to move everything to one side of the equation to have it equal to 0. Right, so what I need to do here is subtract that 24 to move it over from one side of the equation to the other. Right, remember, I'm allowed to do things like that. I'm allowed to add or subtract stuff from one side of the equation as long as I do it on both sides of the equation. Right, and when I subtract that 24 over to the left side, I don't have any constants over here. Right, I don't have any things that are just numbers, so there's nothing to combine that 24 with. So after the x squared plus 5x, I just put that minus 24 at the end. Right, don't make the mistake of doing, well, 5 minus 24, that's going to be a negative 19x. Those are not like terms. You have to keep them separate from each other. Right, only combine things that they have the same variables raised to the same powers. All right, so now x squared plus 5x minus 24 equals 0. We've got our quadratic equation in this form up here. It's equal to 0. That means we are ready to factor it. Okay? So, if you recall factoring, what we have here is a trinomial, right? When you're solving by factoring, now you also have to identify, well, what factoring method do I use to solve this? We have a trinomial here that's a 1x squared, which means it's one of those easier types of factoring. In my opinion, it's an easier type of factoring, at least, where since it's a 1x squared, that gets broken up into just x times x, and then I look for two numbers that are going to multiply to equal negative 24 and add up to equal positive 5. Right, so, and those two numbers are what I'm going to use to fill in the end of those parentheses. Right, remember, if there was a number in front of this x squared here, we would have to use the AC method to factor it, which is a little more complicated. And again, if you don't remember the factoring methods, check out the videos I did on all the different methods for factoring, because some quadratic equations you'll have to use the AC method. Some quadratic equations will be a difference of squares that you have to factor. So all the different factoring methods come up when you're solving these types of equations. All right, so anyway, we're looking for two numbers that multiply to negative 24, add up to 5. So let me make my list of factors of 24. All right, it could be 1 times 24, not going to add up to 5. 2 times 12, not going to work. 3 times 8, that looks good. Because remember, this is actually a negative 24 here. Right, remember, you always have to pay attention to the signs, the positives and negatives when you're doing this. So since it's a negative 24, that means one of these two numbers has to be negative. So since I want it to add up to a positive 5, if I make this a negative 3 and a positive 8, that's going to add up to positive 5. Right, so I get x minus 3 and I get x plus 8 as my factors. Right, x minus 3 times x plus 8 is going to equal 0. And just like when we do factoring, any other type of factoring, if you want to double check, just FOIL it back together and make sure that it equals x squared plus 5x minus 24. All right, and if you do that, you'll see that it does check out. All right, so we've done our factoring. Now, we're not done with the problem, though, right? Remember, when we're just factoring something, we just get the factors and then, okay, we factored it. But if we're using factoring to solve an equation, factoring is not, the whole point of the problem. It's just the tool that we use to get our solution. All right, so after we factor this, we're not quite done yet. Once we have this factored, now we're going to use this zero product property, right? If a times b equals 0, that means either a equals 0 or b equals 0. Well, here's my a, is the x minus 3. Here's my b, is that x plus 8. If these two things multiplied together equal 0, that means one of these two has to be 0. And so what I do after I do my factoring is I split apart my factors. I say x minus 3 is equal to 0, and I say x plus 8 is equal to 0. Right, that's where this zero product property comes in. Right, one of those two has to be 0, or both of them are 0. Right, so to figure out what the solutions to this equation are, I set each one of my factors equal to 0, and now what I have are two pretty simple linear equations that I can solve to get my solutions to this quadratic equation. Right, so for this x minus 3 equals 0, I add 3 to both sides, I get x equals 3. And for this x plus 8 equals 0, if I subtract the 8 on both sides, I get x equals negative 8. right? So there are two solutions then to this quadratic equation that we have up here, x squared plus 5x, equals 24, right? And just like with any other type of equation, if I plug in x equals 3, that's going to give me 3 squared is 9, plus 5 times 3 is going to be 15, and 9 plus 15 does equal 24, so x equals 3 is a good solution. And if I plug in x equals negative 8, see, negative 8 squared would be positive 64. Right? Because remember, when you do negative times a negative, it comes out to a positive. So positive 64. And then 5 times negative 8 would be minus 40. And then 64 minus 40 also equals 24. So negative 8 is also a good solution to this equation. And so I know that the answers I have are correct because I plugged them back in to double check into that original equation. All right, so remember, with linear equations, generally you get one solution. With quadratic equations, a lot of the times you end up with two solutions. Not always. Sometimes with quadratic equations, you only get one solution. Sometimes with a quadratic equation, you might get no solutions at all, right? But in general, you get two most of the time, right? The only time you get one solution is if when you do the factoring and both of those factors are exactly the same. If it was like x minus 3 and then another x minus 3, well, that just gives you the one answer of x equals 3. You just get that answer two times, right? So that's how you would get one solution for a quadratic equation. All right, so that is the factoring method for quadratic equations. You got to get your equation equal to 0, and then if you can factor, you factor it, set each factor individually equal to 0, solve those easier equations, and get your answer. Right? A real common mistake people make when doing this type of problem, and I think it's just a matter of rushing through it, is figuring out, oh, when I factor this, it's going to be a negative 3 and an 8, therefore x equals negative 3 and x equals 8. Right? Those are not the solutions to the problem. Those are the numbers you use to factor, and then when you actually solve the equation, you get positive 3 and negative 8, not negative 3 and positive 8, the numbers that you use for factoring. So just be careful of that. Take your time when you're going through it. And again, if you don't feel that comfortable with factoring, you might want to go back and review some of the videos I did of factoring, do some practice problems of factoring. It's a real common method we use for solving quadratic equations. But like I said, it doesn't always work, right? As we saw when we did some of those videos on factoring, you cannot factor every single expression that you have, right? So when factoring doesn't work, we have other methods that we can use to solve quadratic equations, which I'm going to make some videos of those as well. So check out those so that you can get a good idea of all the different ways that we use to solve quadratic equations, because this is not the whole story for quadratic equations.